for railway feasibility studies, where there are many transportation plans for metropolitan area conducted with this transportation database provided by KTDB, and also some of the projects have used the bus route. They have used the metropolitan area passenger audit tables to do arrangements of bus routes. Or you can do some like an urban logistics plan using the KTDB database. And on average, every year about 100,000 people are visiting these websites on average. It's a lot, because the general people, normal people, I think they do not have any interest about these statistics. It means that at least they are related with transportation areas, or they are working for the public company related with the transportation industry. So it means a lot. And also, in a year, about the people who download the passenger or freight DB from the database center is about 2,000. So it means that the KTDB database have been using so popularly. So I'm going to talk about what is the good points of having the database. So actually, I think the title is the social impact, but this is kind of indirect benefits of having database. Like if we have a good database or accurate database or standardized database, we can have a better the planning and the good accuracy of the demand analysis. So we can enhance the transportation system's convenience, and also we can increase the policy's efficiency. Directly. And this is the economic effects of having database. I think this is the most important thing. The number two, if we don't have a database, each project should spend money about data collection, right? For travel survey or commodity survey. But if we have those kind of standardized database, each project don't need to have collect the data. So roughly in Korea, the direct cost saving is per year is about $130 billion. It's a lot, because hundreds of transportation planning related projects are going on a year in Korea, right? And also, we can provide about new job, like a survey or database establishment for about 45,000 people per year. And also, because we have, national GIS-based database networks, we can save $7 million by just for having the network data. And so it means that we can not only have a better the benefit and cost, we can avoid the redundant research or redundant surveys. So this is the last slide. I'm going to talk about the implication of Thailand. I think you have understood the why we need to have the national transportation database, right? To secure the reliability of the basic transportation data, and increase the efficiency of transportation-related investment. I think if you don't have any standardized transportation database, the feasibility or the demand for each infrastructure could be anything. It is too much elastic. It depends on the researcher or developer, right? It depends on who is the sponsor of the project. But if we have this database, it is very difficult, to be, different from the expected value, right? Actually, I have one interesting story about the database. The second largest city is Busan, right? about 2 years ago, Korean government conducted the urban expressway feasibility study in Busan. But the benefit cost, because the demand is so low, the benefit cost ratio was about 0.5, meaning that we don't have to build the expressway. And the congressman of the region, the parliament, the congressman pushes the KTDB center, and he asks KTDB center to change the audit tables. Yeah, so it sometimes happens, because frankly speaking, we cannot be perfectly independent from the politicians. But assume that we don't have any this kind of database. It could be anything, right? Yeah. So, lastly, I would like to talk about the issues to be cleared by Thailand government. The most important thing is the organization. So, I think the DB Center, Thailand's Transportation Database Center, should be independent, right? Should be independent by law. Otherwise, it could be too much politics, right? And KTDB Center employs 20 PhD and 25 masters. But I think number of employees are not, enough. It means that the establishing and maintaining good quality of a database in transportation area needs a lot of hard work and time and effort and even the technologies. So you need to think about what is the appropriate size of the manpower and what is the qualification for the employees. And also you need to have enough budget, I think. Like, KTDB requires about $10 million per year only for survey, except the salary or the maintenance fees. So it costs a lot. But remember that, we are saving about $130 million by not doing just additional survey, right? So it is very cost-effective way, right, to reduce your government budgets, I think. And also, we have about 13 years of experience of establishing the KTDB Center. And during those periods, we have benchmarked the experience of other countries like European country and America. I think in terms of database, European countries are very advanced, especially in freight analysis area. So we have, the consultants, we have asked many questions. We have reviewed the survey sheets a lot. We have benchmarked a lot. Okay, this is the end of my presentation. I would be happy if you have some questions. No, actually, that's a good question. Actually, the KTDB provides basic network data and basic audit tables and basic model for like a model choice model. And each local agency or, the government corporation like ETA, if they think that they can improve it, you can do it without any permissions. Yeah. Oh, sorry. One important thing. But usually in the case, after the work, usually you need to submit the bank file of the analysis. So the other guys, the other third parties can check it. And this is shameful, but this is important, for Thailand. Like in Korea, if the demand analysis for next 20 years, becomes long. Like, if I predict the travel demand about 100 vehicle, but if it turns out that the traffic volume is about 50 or 60, I can go jail, So we made this kind of law, because, previously before we having this kind of database, the accuracy of the traffic forecasting or the feasibility study was terrible, Like, from Seoul to airport, we have a new railway between Incheon Airport to Seoul Station. The the actual passenger is about only 20% of the predicted one. So yeah, maybe I don't know what is happening in Thailand. Maybe similar, right?
Okay, one question. So this KTDV includes all modes of transportation, correct? So I wonder about air transportation. You collect all the traffic data from the airlines
For
air transportation.
Yes, for domestic we do. Yeah, actually sorry. Actually, like the Korean Air or Asiana Airlines, they are supposed to provide the passenger audit tables and freight audit tables to KTDV centers by law.
For the basic or also international?
Only for domestic.
Okay.
Yeah, because currently we don't care about international passenger or freight audit tables. Yeah, it's too much work. So yeah.
I see. Are there plans to include those? Or
Yeah,
maybe
it's necessary. Right. Yeah, but not for the time being.
That also applies to freight transportation through vessels.
Yeah, right. Yeah.
Water transportation as well. Okay. All right. Thank you.
Hello.
Thank you very much.
Yeah. One more. I didn't see that you did the household interview survey, right? I know. For the passenger travel, you did not use any household interview survey.
We are using household surveys. Basic household survey.
Okay.
The main source of passenger audit tables is coming from the household surveys, but we are trying to move from the conventional way to advanced technology way like PDA. We are trying to move, but the main source is the household surveys, right?
He served as faculty member, a professor, and the transportation division head in the Department of Civil and Environmental Engineering at Utah State University. Dr. Chen has extensive experience in research in application in modeling and analysis of transportation systems, modeling risk-taking route choice behavior, and research on origin-destination trip table estimation. In this talk, he will share with us his work on the decision support system for assessing vulnerability of freight transportation networks. Please join me to welcome Dr. Anthony Chen.
Okay, I think I'll start. First, I would like to thank Dr. Art for involving me in this workshop organizations, and then also Dr. Manil for hosting this event. Thank you. My talk today is going to be on the development of a decision support tool for assessing vulnerability of actually freight transportation networks. So it actually complements the first two speakers very well because we're all talking about freight. And the differences is that I'm going to be talking about developing a decision support system and how to make use of different database to actually conduct a case study. And you heard a talk from Dr. Park on how to develop the Korean transport database, and there is actually a very extensive one. And the one that I'm going to be talking about is existing database from the United States and how we make use of different databases to actually conduct a case study to assess the vulnerability of transport networks. Okay, first I would like to acknowledge the funding that provided by different agencies. First, the Utah Department of Transportation, the Community University Research Initiative grant from Utah State University, and also the Utah Transportation Center for supporting this research, and also collaborators. This project started probably about 4 years ago when I was doing a sabbatical in Thailand in 2007, and there's different students working on this. So here there are 3 of them. They are either former or current student at USU, Ms. Titima, and she's actually in the audience. She was a visiting PhD student from Chulalongkorn to Utah State University, and I should say that congratulations. Right now, she got her doctorate degree, so it's actually Dr. Titima. And also Tawan, Mr. Tawan is also in the audience, and he just got his master's degree from USU and just returned a month ago, and right now he's working for the Department of Highways. So if you have questions about the decision support system, he's actually the one that helped to develop. And also Solowwood, he's my current PhD student. So if you look at it, for this particular project, it happened to be all Thai students. Okay. And here's the outline for my talk. I'll give a brief introduction on motivation for this research, talk about research framework and then the decision support tool, and then show you a case study using the Utah Highway Network and then some potential application. For the motivation, I'm going to keep it very short because the previous 2 speakers already gave a very elaborate introductions about the importance of freight transportation already. So I'm just going to show you one slide here. This basically shows the U.S. freight projections and mode share by value from 2002 to 2035. And this is obtained from a database called Freight Analysis Framework. Okay, and the base year is actually 2002. So it goes all the way to 2035. And this different bar chart right here show you the different mode. Okay, and these 2 axes, one on the left is the percentage and on the right is basically by value. So these are in terms of billions of dollars. Okay, so you can see that in terms of by mode, there are 1, 2, 3, 4, 5, 6, 7 different modes. And the most important one is actually truck. So in other words, most of the freight being transported in the United States is actually truck. It has about probably more than 75% in 2002, and it seems to be fairly constant. So even in 2035, there's still a good 70%, over 70% will be carried by truck. So basically, truck will be an important mode of freight transportation. And from 2002 to 2035, there is actually an increase of over 150% in terms of value. So you can see that the freight will increase and significantly. Okay. And the most important point about freight transportation is actually the bottlenecks or the choke point, okay? And I got these 2 definitions from the Washington Department of Transportation. So they define bottlenecks are places where roadway physically narrow, causing congestion. So basically, example, lane drop, or maybe the shoulder is narrowing. And another one is called choke points. And these are places where delay occur because of traffic interference and roadway configuration. So this picture shows here, there may not be a lane drop, but there's significant congestion. But in this particular talk, I'm going to use these 2 interchangeably. So choke point and bottleneck basically to me mean the same. And those are the ones that we need to focus on because those are the ones that cause the most delay for freight transportation. Okay, here's a few more examples about choke point disruption. And I mainly focus on bridges because the case study that I'm going to talk about is on bridges. Okay, so it can be due to many different reasons. So for this one is due to an earthquake. This is from in San Francisco in 1989. There was an earthquake, so several of the bridges actually collapsed. Or it could be due to collision of the barge. So this one is in Texas, and this one is in Oklahoma. Or it could be just due to no reason. So this one is the most recent one in 2007. There is a bridge collapse in Minneapolis, and it just